Hello, today we're going to be looking at some graphs and some equations and determining whether or not we have proportional relationships. Two variables, which usually will be x and y, have a proportional relationship if all the ratios of the variables are equivalent. So that means no matter what your x and y are, if you were to make a fraction out of your x and y, they would always reduce to the same fraction. Another way to say that is one variable is always a constant times the other variable. In equation form, we usually think of it like this: y equals kx, where that k is the constant value. We call that k the constant proportionality. Sometimes people also call that the unit rate. If you think back to your other math classes, you may have seen the equation y equals mx plus b before. You know, m is your slope and b is your y-intercept. Notice that y equals kx is really similar, except for it doesn't have a plus b at the end. And so that means the y-intercept would be 0. We know y equals mx plus b gives us a line. Specifically, y equals mx, which is the same idea as y equals kx, is going to be a line where the y-intercept is 0. That means the graph is crossing the y-axis at 0, something like this. So part of a graph being representative of a proportional relationship is that the y-intercept where it crosses the y-axis is at 0. So we see that in some of these graphs, but the ones that are not proportional, we'll see the y-intercept is in a different spot. Also, notice our graph needs to be a straight line, not a curve, not anything else. So we have a few examples here, just scrolling through quickly, of we're looking at two graphs, which ones are proportional relationships. So in the notes, I actually labeled these as graph 1 and graph 2. Graph 1, y-intercept is 0. It is a straight line, so this one is a proportional relationship. Graph 2, y-intercept is also 0. Graph is a straight line, so both of these, number 1 and number 2, are proportional. Next example, both graphs are straight lines. However, notice that graph 1 does have the y-intercept at 0, which we're looking for, so graph 1 is proportional. Graph 2 is not. The y-intercept would be somewhere down here in the negatives. We actually don't see where the y-intercept is. Notice that the start of the graph is not at 0, 0. It's at x equals 1 point something. So graph 2 is not proportional because it does not cross the y-axis at 0. Next set of two graphs, graph 1 and graph 2. Graph 1 does not cross the y-axis at 0, so it is not proportional. But graph 2 does. Graph 2 is also a straight line, so graph 2 is proportional. I meant to cross this one just to make it clear. Last graph example. Graph 1, y-intercept is at 0, 0. Graph is a straight line, so graph 1 is proportional. Graph 2 does have the y-intercept we're looking for. Y-intercept is at 0, but notice the graph is actually, it looks like half of a parabola. And so since it is not a line, it's going to be some sort of other relationship that's not a direct or proportional relationship. So only graph 1 for that set. The rest of these, we're going to be looking at two equations. And so I'm going to rewrite the one we looked at earlier. If we have a proportional relationship going on, our equation is going to look like y equals kx. And k is just a placeholder for some number. That number could be a fraction, could be a decimal, could be an integer. Any of those are okay, as long as it is just a number, not a variable, nothing else. So I'm going to call these equation A and B. I'm going to go ahead and label all of them before I get carried away here. For this first set, equation A is y equals x, which is the same as y equals 1x. Equation B is y equals 6x. Both of those are in that form of y equals something x. Nothing added or subtracted at the end of the equation, no exponents or anything else strange happening there. So both of these are proportional because they're y equals number times x. Same idea with the next section, or the next set of equations. We have y equals 2x, y equals 3x. They're both y equals something times x, where that something is a number. So both A and B are proportional equations in that set. In the next set, notice that equation A has this plus 4 at the end of the equation. That would mean the graph for equation A would cross the y-axis at 4 instead of at 0. So from a graphing perspective, we can see it's not proportional. From an equation perspective, notice that y equals kx doesn't have anything added on to the end here. So for this set, only equation B is proportional because it's the only one that's just y equals number times x. For the last set here, we have y equals 5x squared, y equals 3/2 x. It is perfectly fine for the number in front of x to be a fraction, so b is proportional. 3/2 times x is still number times x. Equation A is not proportional specifically because of that exponent. Also, from a graphing perspective, it would look like a parabola, which would not follow our qualifications for being proportional either. So to recap, graph-wise, we are looking for a proportional relationship has to be a line that crosses the y-axis at 0. Equation-wise, we're looking for y equals kx, where k is just some number. That is it. Have a fantastic day.